Let's talk about the ambiguous case. What is the ambiguous case? Well, the ambiguous case is something that comes into play when we're trying to solve triangles. What does it mean to solve a triangle? It means you want to solve for all the sides and all the angles. So for example, if I have a triangle that looks like this, and it's a 90-degree triangle, and this side is 2, and I say this side is A and this side is B, and here you have angle A, and up here this angle is 30 degrees, and you say solve this triangle, what would you do? Well, I could solve angle A first, because all the angles should add up to 180. So 180 minus 90 minus 30 should equal angle A. Well, that's just going to mean that angle A is equal to 60 degrees, right? So that's the first part. And then the next part is, well, okay, I want to find one of these sides. How about I try to solve for side B first, right? Because sine of 30 degrees is equal to the opposite over hypotenuse, so 2 over b. Solve for b. b equals 2 over sine 30, right? You just swap those two terms. 2 over sine 30, that's equal to 4, so b is equal to 4. And then to solve for a, you could say something like tan of 30 degrees is equal to opposite over adjacent, so 2 over a. So therefore a is equal to 2 divided by tan 30 degrees, and therefore a is equal to approximately 3.46. Just like that. Now the triangle's solved, right? So solving triangles is something we're comfortable doing, right? We've done them before, but sometimes things aren't so simple, right? Sometimes they're a little bit more complicated. Sometimes they look like this, where this is maybe 30 degrees, and this here is angle B, and this over here, you could call angle C. And you're given a couple sides, right? You find out this is 5, this is 10, and then this is side A, right? Or something to that effect. And you're told that, okay, solve for everything. Well, how do you do that? Well, you could say sine of 30 over 10 is equal to sine C over 5, and then solve for C, right? You're going to find out that C is equal to the sine inverse of 5 sine 30 over 10. Again, this is just review, so we're moving a little fast. And then C is equal to 14.48 degrees. You can label that there, just like that. Okay. What else? Well, we can find angle B now by subtracting, right? 180 minus 30 minus 14.48. This is going to equal angle B. So angle B is equal to 135.52 degrees approximately, right? B is equal to 135.52 degrees. Okay, so that's the angles. Now how do you find side A? Well, for side A, we could just say A over sine 135.52 degrees is equal to 10 over sine 30 degrees, right? Another sine law. And if you calculate A, multiply both sides by this denominator, A is going to equal 14. So that's your answer, right? You've solved the triangle, we figured out all the angles and all the sides. Now, those cases were all very straightforward. When we talk about the ambiguous case, it's not so straightforward. So let's talk about the ambiguous case. So first off, what is the ambiguous case, right? What is this mysterious thing I keep talking about? Well, when we have a triangle, it looks like this, and I say this is angle A, and this is side C, and this is side A. If I give you these pieces of information, I don't give you the drawing, I just tell you what these things are. You could say, all right, well, the triangle probably looks like this. But how do you know the triangle is actually real? How do you know that the triangle doesn't go something like this, and then, with this A value and the C value, how do we know that this little a here isn't long enough to reach the bottom, right? We assume the triangle closes, but what if it doesn't, right? What if I give you these values and it turns out that it doesn't actually close shut? This is a possibility, right? We have to check and make sure this is not what's happening. In addition to this, how do I know that this is what the triangle looks like when I give you A, C, and A, and that it's not actually something like this, where this is A, C, and A, right? We assume that the side A goes out, but how do we know it doesn't go the other way like this and close the triangle like that to make it skinny? That's also a possibility, right? And so we have to figure out what we're dealing with when we're given measurements of a triangle, right? This is what's known as the ambiguous case. So what we can do is we can categorize these scenarios based on some conditions. So we're going to have some conditions, and we're going to have some possible triangles. And you're going to see when each triangle occurs based on these conditions. So let's say that A is less than H. What the heck is A? What the heck is H? Well, A, as I talked about up here, the little a, is this side here. Okay? That side that closes things up, all right, potentially. And I can draw a shape here. So you have this triangle like this, where this is A, this is angle A, and this is side C. H in this case is your height, so the height from the top to the bottom like that. That's your height. If A is less than H, which is what we described here in the condition, then that means that this arm is not going to touch the ground. It's not long enough, right? Even if it goes straight down like this, it's not going to reach the ground because it's smaller than your H, right? It's too short. So the triangle in this case doesn't close. So there's no triangle possible. So if you check to see if your A length is shorter or bigger than H and you find out it's shorter than H, then there's no triangle possible. The scenario they describe to you is not real. Okay? That's one condition. Another condition would be if A is equal to H. So using the same kind of idea here, the same drawing, what if A is the exact same length as H? Well, if A is the same length as H, so again this is angle A, this is side C, and then we have your height like that. If A is the same height as H, then when I have it to the right like this, it's not going to touch the ground. And if I go to the left, it's not going to quite touch the ground. But when I swing it right into the middle, because it's the exact height of H, it's going to touch the ground like that, meaning it has to go straight down to reach, to close, meaning you have a 90-degree angle. So if A is equal to H, what that means is we have a right angle triangle. Okay? Now this is important because you might not know, right? You might not be told that it's a 90-degree triangle at first. But once you figure this out and you know it's 90 degrees, your life will get a lot easier with solving the triangle, right? So those are two conditions that we have so far. There's also a couple more. You could have A is larger than H, but it's less than C. What is C? C is the side here, the side that's attached to your angle A, right? So in this scenario, there's a couple things that are possible, right? So you have H here. Here's your A, here's your C, here's your angle A. If A is bigger than your height, but it's less than C, it can go like this, or it could swing the other way and go like this, right? Where this is now your height, right? That's your height. So if A is less than C, but it's bigger than H, it can go out like that, or it can come in and look like this, right? The skinnier triangle. Both of these triangles have the same C value, the same A value. Those lengths are the same in both cases, and angle A is the same. The only thing that changes is the base, right? Because this arm is swinging in versus swinging out. So you actually have two triangles possible here, right? You have two possible triangles. So if you're doing a question like this and your A value you figure out is between your height and your C, that means you have two triangles to solve for. You gotta do twice the work, okay? If you don't recognize that, you're only gonna get half marks because you forgot about the other triangle. So that's the third condition. Now the fourth condition says that A is larger or equal to C, okay? Because if A is bigger than C, or if it's equal to it, this second possibility here is not going to be possible. A would not be able to fit inside like this if it's bigger than C, or if it's equal to it, meaning that there's only one triangle possible. I'll try to draw it so it makes sense to you. Imagine this is your angle A, that's side C, this is side A. Side A is bigger than C, so of course if this swings in, it's going to come out all the way to here. It's going to be too long, right? So there's only one triangle possible if A is bigger than C, right? One possible triangle. So that's the fourth condition. If A is less than your height, the triangle is not possible. It won't close. If A is equal to your height, then it's a right angle triangle. If A is between your height and your C, then there's two possible triangles. And if A is bigger than C, there's just one triangle, like this, right? It's one big scalene triangle, just like that. Okay? Let's do some examples. Example 1. We're told that angle A is equal to 70 degrees. We're told that side C is equal to 10 centimeters, and we're told that A is equal to 6 centimeters. So the triangle we're talking about, we don't know if it closes yet, so I'm just going to draw it like that, because I'm not sure how long this is, if it's going to close or what. This is 10, this is 70 degrees, and this is 6. So for sure we know that your A value is less than C, right? That's okay, it can still close, right? It just depends on how big it is exactly, right? So let's compare it to H, right? That's kind of important for most of those conditions, is we have to compare it to H. So how do I solve for H? Well, if you draw your imaginary height here, you make a right angle triangle, right? You have your hypotenuse of 10, and H is your opposite, right, to the 70 degrees. So you could say sine 70 is equal to opposite, which is your height, over the hypotenuse, which is 10. Multiply by 10, 10 sine 70 degrees equals your height. Therefore, the height is equal to 9.4 centimeters. Okay, so what's happening here? Well, 9.4 is bigger than 6, right? Therefore, your height is bigger than your A value. So when A is less than your height, there's no triangle possible, right? This example here is not possible because this is too small, right? This height is 10. This length here, this A, is too small. It can't reach the bottom no matter which way it swings. It's not going to touch the bottom. Therefore, your triangle cannot close. Okay? That's question 1. Let's look at example 2. Example 2 says A is equal to 30 degrees. C is equal to 10 meters. A is equal to 5 meters. So again, I'm going to draw it the same way to start. I don't know if it closes or not yet, so I'm just going to leave it like that. That's 30 degrees, that's 10, that's 5. So again, you kind of want to solve for your height to see if it's bigger than your A value or not. So sine of 30 degrees is equal to your height is your opposite side, so height over hypotenuse, which is 10. So 10 sine 30 equals height. Calculate that. You can use your calculator. Your height is equal to 5 meters. So in this case, that's equal to A, right? Your height is equal to A. That's that second condition, right? That means what we have is a right angle triangle where this 5 is coming straight down. So the real triangle looks like this, where this is 5, that's your A, this is 10, and this is 30. Now that we know what triangle we have, we can go ahead and we can solve for everything, right? So I know this top angle up here is going to be 60, and the reason I know that is because the angles have to add up to 180, so that's the first thing you can find. Then you have to find the side on the bottom. To find that side, I think I'm going to do a cos. Cos of 30 degrees equals adjacent, which is that bottom length, we'll call that x, over hypotenuse, which is 10. So 10 cos 30 is equal to x, and then x is going to equal 8.66 meters approximately. So that's this length on the bottom is 8.66. So we've successfully solved for all the angles and all the sides. You're done this question. Let's look at example 3. So example 3 says we have an angle of 30 degrees, we have a C of 10 centimeters, and we have an A value of 6 centimeters. So again, we want to sketch this out. We don't know if it quite closes or not, so I'm just going to leave it like that for now. This is 30 degrees, this is 10, this is 6. We have to figure out what the height is to compare to our A value. So let's solve for the height. Sine 30 is equal to h over 10, so h equals 10 sine 30, so h equals 5 centimeters, right? Same calculation as last time, actually. So you get h equals 5. So what we find out is that your A value is 6. That's bigger than your height, right? But it's actually also less than C. Your A value is bigger than the height, and it's less than C, right? Because you got 6 for your A, that's bigger than the 5, which is your height, and it's less than the 10, which is C, meaning this is the third condition, right? Third condition where you have two possible triangles. So let's take a look at what these triangles look like. The first one is going to look like this. It's that skinny one. And then the other one is when that arm swings out the other way, and it goes like this. Okay? So in this case, both of these are 30 degrees, just like that. Both of these lengths are 10, and both of these lengths are 6, right? Just like that. Everything else, though, is going to be different. And the heights of these both are 5, right? That's one thing to keep in mind. Now, how can we solve for these triangles? Let's start with this one on the left, right? So this one on the left, let's say we label this angle here angle C. How can we solve for that angle? Well, I would say that sine of C divided by 10 is equal to sine of 30 over 6. So just use sine law, right? If you isolate C, you get C is equal to sine inverse of 10 sine 30 over 6. So you're going to figure out that C is equal to 56.44 degrees. Now hang on a second. 56.44, that's less than 90. If you look at this angle, it looks like it's an obtuse angle, meaning it's bigger than 90 degrees. So why am I getting this answer? Well, this answer is actually on this side, because when you calculate like this, it's always going to give you the related acute angle, right? It's always going to give you the little angle as the answer. So this answer that we get here is actually the angle for this triangle, 56.44 degrees. The way you figure out this one in here is by subtracting 56.44 from 180, because this whole thing here is 180. So it's not actually equal to 56.44 in this case. C will equal 180 minus 56.44, which is going to equal 123.56 degrees approximately. So that's this angle in here. That's equal to C. So if you want to label it, put an arrow because we're running out of room, 123.56 degrees. From that, you can find this angle on the top because they all have to add up to 180. So you could say 180 minus 123.56 minus 30, right? That's going to equal what? Well, that ends up equaling 26.44 degrees. So this angle here is 26.44 degrees. So you now have all the angles, and you have two of the sides. You just have to find the base. We'll call the base x, right? Why not? And we'll calculate for x. How do we do that? Well, we could do another sine law, right? I could say sine of 30 over 6, right? Because 30 and 6 are across from each other, is equal to sine of that angle we just found, 26.44 over x, because x is across from it. It's on the bottom. Then we can isolate for x, right? X is going to equal 6 sine 26.44 divided by sine 30, right? Move the x up here, move the 6 up here, move this thing down here. Whenever you cross the equal sign, it goes from the top to the bottom or from the bottom to the top. So it's pretty easy to isolate for something when you have two fractions, right? As long as you know that trick. Calculate this, and you're going to get 5.34 centimeters. That's the last side we had to find. The triangle is now solved. Let's work on this one on the right now. We can find this angle on the top pretty easily, right? 180 minus 56.44 minus 30 degrees. That is going to equal 93.56. 93.56 degrees. All right, now we have to find the last side, right? And to do that, we can just do a sine law, right? I could say sine 30 over 6 is equal to sine of 93.56 divided by, we'll call this one x. And then you solve for x. X is equal to 6 sine 93.56 degrees over sine 30 degrees. Therefore, x is equal to 11.98 centimeters. Now this triangle is solved. You have all the angles and all the sides. And that's it. So this condition is probably the most difficult, or at least time consuming, because you have two different triangles to solve for, and there's that trick where you think you get the angle, but that's actually the angle for the other one. And you have to recognize that, right? So with that in mind, let's go to the final example, example 4. And you can probably guess what's going to happen based on the trend so far. We're going through each condition. So for this question, we have an angle of 40 degrees. We're told that C is equal to 10 meters and A is equal to 12 meters, just like that. So we have something like this. We don't exactly know what it's going to look like, but this is 40 degrees, this is 10, this is 12. Right off the bat, you can see that A is bigger than C, right? Because 12 is bigger than 10. Therefore, it's the fourth condition. Therefore, we have that one triangle, right? The big triangle. That looks something like this, because this side is longer than this side. So this is the only way this is possible. Now, how do we figure out everything else? Well, we can do a sine law to start figuring out some of these angles, like this one over here. We'll call that angle C. I could do sine C over 10 equals sine 40 over 12. Solve for C. C is equal to sine inverse 10 sine 40 over 12, like that. Therefore, C will be equal to 32.4 degrees. You can find the remaining angle by subtracting those from 180, right? 180 minus 40 minus 32.4. That's going to equal 107.6 degrees. Just like that. Okay, one more side you have to find. Let's do another sine law, right? We'll call that B for base. Why not? So B over sine 107.6 is equal to 12 over sine 40, right? Okay, we solve for B. B is equal to 12 sine 107.6 degrees divided by sine 40 degrees. Therefore, B is equal to 17.8 meters. And that's it. We've solved for the triangle. We have all the angles and all the sides. So that's an example of each of the four conditions within the ambiguous case. Hopefully that gives you enough exposure to that you're able to practice these questions confidently and get this subject down.